All right, so hypothesis testing, it's going to be something that we do for the rest of the year, okay? Now, the idea, though, is that once you learn hypothesis testing, we're using the first technique. So the first thing we'll do will be much like what we did with confidence intervals. We learn a first confidence interval with trying to estimate the mean when sigma was known, okay? We will do the exact same thing for hypothesis testing. We will try to do a hypothesis test for the mean when we know sigma. Once we learn that, the process is identical for all other distributions. Okay, so we'll run through trying to run hypothesis tests on the mean when we know sigma or a standard deviation of the population. Then we'll run through it when we don't know the population standard deviation, so we'll use the student t-test. We can do it using proportions. We'll do it using, depending on the time that we have, we could go through and do it with chi-squareds, so on variance and standard deviation. And we'll most certainly do it on the difference of two populations, okay, the mean of two populations. And then Chapter 10 is all about looking at two samples and seeing if those two samples differ, okay, using hypothesis testing. So from today to the end of the year is all about hypothesis testing, and hopefully in the first 2 or 3 days here, we understand what the formatting of a hypothesis test is, learn the notation, and then the testing isn't all that difficult. We already know how to do most of the individual components of testing. We know how to find alpha and alpha over 2. We know how to find z-scores in a table or using inverse norm or normal.dist on Excel. We've learned all these smaller components that are going to be mashed together to do hypothesis testing. Okay, and that's kind of what this first bullet here says. Overall hypothesis testing is the same idea all the time. However, the approach and distributions that we use to conduct testing will be different based on sample sizes, known components, etc. Okay, and really what that does is it is going to, depending on sample sizes, depending on whether you know population standard deviation, that kind of stuff, will dictate what distribution we use. Okay, so some key terms here are hypothesis. Hypothesis is a premise or claim that we want to test. Okay, meaning, using the P&G example, I think that's appropriate for us since it's so close, and they do this regularly there. Okay, if I'm an employee and I believe that I make the claim that there's supposed to be 64 ounces in a bottle of detergent, but I'm making the claim that it is much less than 64 ounces. That is my hypothesis. Okay, and we will then test that. Okay, or we can look at it as P&G says that there is 64 ounces in there, and I believe that it's different, so we're going to test that argument. Does that make sense? Okay, so that's the kind of thing we're doing. We do hypothesis testing when we talk about medications. Okay, when we're creating medications, administering them, doing like trial studies or trial research with new medicines. We will do hypothesis testing with that. Okay. A lot of hypothesis testing takes place in research. A lot takes place in medical research. The null hypothesis. What's the word null mean? Null and void. So what's that mean? What's null mean? None. Okay. So a null hypothesis, and the notation that we use for this is H with a subscript of 0. Okay, that 0, it does nothing mathematically. It's all notation. It just refers to the null, what we call the null hypothesis. It's the default hypothesis, or the hypothesis that is already established. Okay, which means it's the thing that shows no change. Okay. If we can show change from the null hypothesis, then maybe we've got sufficient evidence to maybe what we call reject the null hypothesis. Okay. It says the currently accepted value for a parameter. Okay. What we will do is we will see some story problems. Essentially, they'll give us a scenario, and we have to be able to decipher what is the null hypothesis. What is the established value that we are all agreeing upon as maybe being the mean? Okay. Then we have what we call the alternative hypothesis, sometimes referred to as the research hypothesis. Okay. And it involves the claim to be tested. Okay, the notation for that, there's a couple different ways you'll see notation for this, and I go back and forth throughout my notes. H sub A, okay, that's probably the easiest one to realize that that's the alternative hypothesis. But sometimes we use H sub 1, okay, the null hypothesis sub 0, alternative hypothesis sub 1. Just with that, staying the consistency with using numbers, sometimes we'll do that. An hypothesis test is a process that uses sample statistics to test a claim about the value of a population parameter. Okay, so P&G is interested in making sure that when you go to Myers and you buy some Tide off the shelf, that you can be guaranteed that you are getting the same bottle that is in front as what is behind it, right? You don't have to grab each one and decipher which is the best one here. Okay. In order to do that, make sure that that is happening, they will take maybe every 100th bottle off of each line, and they will do testing on it. They will measure the volume, right? Okay, it's called systematic sampling. Okay, so maybe they make 100,000 bottles of detergent this month, and they take off every 100th. Okay, so they would have 1,000 bottles that they could measure, right? Okay, they measure those, and if they are within the tolerance that is acceptable, then hypothesis out of that sample, okay, the hypothesis testing will tell them something about their population. If that sample demonstrates that there is 64 ounces in the mean of that sample, then we can make the argument that there's 64 ounces in the mean of the population, okay, with a particular level of confidence. All right. Hypothesis contains opposing viewpoints. Okay, so your null hypothesis, once we establish that, your alternative hypothesis will be the opposite. Okay. Your null hypothesis always includes equality. Okay. You might want to write that down. Your null hypothesis always contains equality. Okay. Now it might be less than equal to, or greater than or equal to, or just equal to. Okay. But the null hypothesis always, 100% of the time, contains equality. And if we can remember that, that's going to help us decipher when we read a scenario what the null hypothesis is. When they use the word is in a scenario, algebraically, is the word equals to, right? Or is the statement equal to? Okay, so that's going to help us decide when we read something what is the null hypothesis. And once you know the null hypothesis, then, and we establish that, then the opposite viewpoint is the alternative hypothesis. Okay, we will always assume that the null hypothesis is always true. Okay, that's the assumption that you make always. Okay, if we go back to what we call the null hypothesis, it's the default hypothesis. Okay, it's what is already established, currently accepted value. Okay, so we're going to make the assumption that once we locate that and identify it, it's true. Okay, until our data provides evidence to the contrary. Okay? Once our sample data says you can no longer accept this null hypothesis, we will always accept it. We'll always say it's true until otherwise realized. Does that kind of make sense? Okay. So here are some verbal statements that you will see. So I think that, let me show you this real quick before we do anything. When we write a null hypothesis, so what we'll do, always, every single time that we come across a scenario that we want to test, we will identify two things. We'll write down H sub 0, and then we'll write a colon, and we'll write H sub A, or H sub 1, however you want to write it, and a colon. Okay? We'll deal with the parameter that we're interested in, so we'll say mu, and it'll be mu in both of these. Okay? So if I say mu is some number, okay? Maybe it's, let's go to the P&G example, 64 ounces. So I'm going to say the currently accepted mean for the volume of detergent in Tide from P&G is 64 ounces. The alternative hypothesis would be the opposing viewpoint. So what is the opposing viewpoint to equality? If things are equal, what is the complete opposite of that? Not equal. So I would write my alternative hypothesis that way. Okay? So that would establish the idea that the researcher is maybe arguing that I think the machine is malfunctioning, but I don't know if it's going to be more than 64 or less than 64. Does that make sense? Okay. So when you see not equal to, basically that's where we could reject, we call it rejecting the null hypothesis, if we were to have data that suggests that mu is above 64 or that mu is less than 64 from our sample data. Okay. Now, and it will have to be, if I just say like 63.999, that's less than 64, but will it be enough, will it be significantly lower than 64 that we can actually reject the mean, okay, reject the null hypothesis. So that's an opposing viewpoint. Now, let's say that P&G makes the claim that the mean volume is less than or equal to 64 ounces. Less than or equal to 64 ounces. Okay? Remember, the null hypothesis has to include equality. Okay? So it can have a less than sign. And some researchers, even if it's less than or equal to, they will just write equal. Okay? I'm going to try as we go through, and I think most of the questions that I've seen in MathXL and things that I've put into my notes from other textbooks will always use either less than or equal to, or greater than or equal to. Okay? But like I said, sometimes they will just eliminate using the inequality symbol and we'll just put equal to here. Okay? But if less than or equal to is the null hypothesis, what is the opposite viewpoint? It would be greater than, right? You guys get, we're talking, essentially these are complement ideas, right? Okay? So if this was greater than or equal to, then the alternative hypothesis would be less than, right? Okay? So that's how we're going to write our null and alternative hypotheses. Coming over here, you can see really all the different ways that we could write. It says greater than or equal to. So verbal statement, H sub 0 says the mean is. And that's what you're going to see people talk about in these scenarios. They will say somehow through the structure of their wording, you're going to come across the phrase, the mean is, and then greater than or equal to, at least K, not less than K, something like that. And that terminology will all lead to this idea here. Greater than or equal to obviously means greater than or equal to. I mean, that's, I don't know a better way to say that. You learn that in 6th grade, okay? But these then are analogous to that. When it says at least K or not less than K, okay, those all equate to that phrase greater than or equal to. Okay, so a lot of times when I see these in wording in a problem, I'll white them out and replace it with that, because I think that one is just more obvious, right? It's more direct. Okay, so if that's the case for the null hypothesis, okay, if I say greater than or equal to is the null hypothesis, then the opposite viewpoint is less than. Okay, and then you can see these as well. So what's going to happen is that the alternative hypothesis generally is not going to be something that is written in the problem. Okay, so we really won't have to worry about really these things here very often. Here's less than or equal to. So analogous statements are at most K, no more than K. And then you've got equal to K. They might say the mean is K, when the mean is exactly K. And these aren't the only options, but they give you an idea of how we take the verbal statement and convert it into our mathematical statement. So all of these are saying the word mean. Okay, we'd be looking at mu for the population. So what we're trying to do here is take sample data and make a conclusion about the population. Okay, so we're going to use statistics. Remember, statistics are the numerical quantities that are attached to samples, right? So we're going to take statistical data and see if they can tell us something about the parameter, okay, or the numerical quantities attached to the population. So that being said, we should be able to make, this is what I said at the beginning, similar statements about P, which is the population proportion, about sigma squared, which is the variance, and about sigma, which is the standard deviation. And those are all parameters for the population. And that's what we got to put. That's once we learn how to do this initially with the mean in the next couple of days, and we get good at that, then it's just a slight alteration depending on whether we're estimating P or sigma squared. And basically what that does is it forces us to use a different formula for the test statistic. Okay, so when we find the z-score for a mean, we're going to do x bar, the sample mean, minus the population mean, divided by the standard deviation, divided by the square root of n. We've been doing that since 8.1. We've actually been doing that since the central limit theorem. Okay, that's our test statistic. When we talk about proportions, that test statistic is a little bit different. The formula to find the z-score a little bit different. Okay, when we do variance, we're working with chi-square, so that formula is a little bit different. Okay, but that's really the only thing that will be different as we work through hypothesis testing. It says note, the null hypothesis always has a symbol with equality in it. I think we've already said that. H sub A never has equality in it. Your alternative hypothesis or research hypothesis is always less than, greater than, or not equal to. Okay? So the choice of symbol depends on the wording of the hypothesis test. So, however, be aware that many researchers use equals in the null hypothesis, even with greater than or less than symbols in the alternative hypothesis. This practice is acceptable because we only make decisions to reject or not reject the null hypothesis. So, what we end up doing, okay, we will never say anything initially about the alternative hypothesis. Okay, we will make our null hypothesis or realize our null hypothesis, and that is the accepted true value for the mean. Okay, we will then run through our testing to see if we reject that or if we do not reject that. And that's the wording that we always use: reject, or not reject. Okay? And what's important to understand is that when we use sample data to either reject or not reject a null hypothesis, okay, there could be error in that. Okay, we could be wrong, okay, because of sampling techniques, okay, random sampling error. It's kind of the idea, and you'll see me compare I think in the next section we compare this to like a court case. Can we go to court? What are we trying to do in court to a like a plaintiff? What are we trying to do to that person? As a prosecutor, my goal is to do what? I'm going to see. I'm going to try to convince. I'm going to see if I can have enough evidence to show that they are guilty or likely guilty of that crime. Right? Okay. In a court case, if you think about it, we assume, what is the null hypothesis in a court case? What is the assumed in the United States court system? What is the assumed null hypothesis of any person that goes to trial? Innocent. They are innocent until you can provide, as the prosecutor, can provide evidence to say to the contrary, right? Okay. So that innocence is the null hypothesis. Okay. Now, as we go through trial and that kind of stuff, have people that are innocent been convicted and put to jail? Yeah, that's an error, right? You guys agree with that? Okay. Would you also agree that there has been people that are guilty, that are truly guilty, but the court system was unable to convict them? Okay, that's another type of error. Okay. There are also people that have been innocent, and the courts have failed to convict them. So that would be a correct testing. Does that make sense? They did that correctly. There's also been people that are guilty, 100% guilty, and the court has shown that they are guilty, and they've been convicted. And that would also be a success as well, right? Okay. And we'll talk about that. It's called type 1 and type 2 error. And sometimes those things are, if we're looking at a court case scenario, if, let's say, Chuck is being prosecuted for murder, and he is 100%, we know that Chuck did not do it. Okay? Or maybe in Chuck's heart, he knows he did not do it. Okay? He'd be maybe the only one that knows this. But the court system convicts him, and he goes on death row. Would that be a very bad error? Yes. Okay? Now, likewise, let's say Chuck gets convicted of murder and did it, he's maybe done it multiple times, and they release him. They do not convict him. Is that really bad error? Yes. Okay? So there are situations where the errors can be very bad, and there is also times where errors maybe not be so bad. Okay, we'll talk about that. But the idea is that we always assume that the null hypothesis or the innocence is always true until we can establish or generate enough data to refute that. Okay, we call it reject or not reject the null hypothesis. Okay, so we got a scenario here. It says you are a line operator at Procter & Gamble. The machine is set to dispense 32 ounces of detergent into the bottle. Okay? So you believe that the machine is faulty and is not dispensing 32 ounces. Okay? So what is the accepted, established mean for this scenario? 32 ounces. The machine is set to that. That is what we are assuming is going into each of these bottles. So that's our null hypothesis. Okay? And because it says you are a line operator at Procter & Gamble, the machine is set to 32 ounces. So that's why we've got here our null hypothesis, mu equals 32 ounces. You believe the machine is faulty and is not dispensing 32 ounces. Now, when it says is not dispensing 32 ounces, does it say which direction? Nope. Doesn't say greater than or less than. So then we assume that not equals would be the alternative hypothesis. And basically what we'll do then is that we will, through our sampling, we will hopefully either recognize that we are far enough below 32 ounces or far enough above 32 ounces to either say, nope, this is fine, it's not dispensing more than 32 ounces, or we reject this, and when we reject that, the only thing that we are left with then is the idea that, yep, it is not 32 ounces. Does that make sense? Okay. The key phrasing, though, and we'll talk about this later on, I'll give you ways of summarizing our results. Right now, we will never say, just because I reject this, that I accept this. Okay? We will summarize that this is probable, but I'm not going to accept it because we're only looking at samples, and unless I have the entire population, I cannot be 100% certain. Peyton. I'm going to try to keep away from that right now, but you'll be able to see that when, like for instance, if that were the case, it says you are a line operator at. I guess I'm not going to stay away from that. I think I interpret your question differently. It says you are a line operator, programmable machine is set to dispense 32 ounces of detergent into each bottle. You believe the machine is dispensing less than 32 ounces. So then your alternative hypothesis would be less than. Okay. Eventually, we're going to talk. I'll probably talk about this in more detail tomorrow because I think we're going to run out of time here today. We want to look at something that's called a claim. Okay. One of those two hypotheses, either the null or alternative, and it alternates or changes from scenario to scenario, depending on the wording, is what we call the claim. Okay. Some ways for us to identify which hypothesis is the claim. It says, does the original claim include equality? Okay. If so, then the null hypothesis is what we're going to refer to as the claim. So does the original claim include inequality? If so, then the null hypothesis is the claim. Okay. And there's different ways, especially from the perspective of the researcher. There's ways that we can word our question or word our investigative questions to establish which one's going to be the claim. Okay. And like I said, we'll get into more of this later on. It says if the given claim contains equality or statement of no change, if the given claim contains equality or a statement of no change from the given or accepted condition, then the null hypothesis is the claim. Otherwise, I should probably put should be a subscript, then the alternative hypothesis is the claim. If the given claim contains equality or a statement of no change, okay, then the null hypothesis is the claim. Yes? You don't need to write down today. We'll see it again tomorrow. So as a researcher, if a researcher is looking for a conclusion that supports their claim, okay, so let's say that I want to make I'm a researcher. I make the claim that there is not 32 ounces in this bottle or these bottles, and I want evidence to support that. Okay, then I'm going to make my alternative hypothesis the claim. Okay, because I can structure the wording as I see fit. Okay, says if the researcher is ultimately the opposition and wants to a conclusion that rejects the claim. Remember the thing that we reject. We reject the null hypothesis, right? So through my wording, then, I will make the null hypothesis my claim. And then my sampling data will tell me whether to reject that or not. So note the claim is the alternative hypothesis. The researcher wants a conclusion that supports their claim, so they need it worded as the alternative hypothesis. If the researcher wanted a conclusion that rejected their claim, it would have needed to be written as a null hypothesis. This is difficult for some people to realize, and we'll talk about more of this later. But these are really all kind of analogous statements, okay, different ways of thinking about it. We will, as we go through example, starting tomorrow, as many examples as we can, we will spend time just reading a scenario and say, okay, here's the null hypothesis, here's the alternative hypothesis, which one is the claim? Okay, because that's going to be one of probably the most important things that we do early on with this stuff. Okay. Here it says we want to test whether the mean GPA of students in American colleges is different from 2.0 out of 4.0. Determine the null and alternative hypotheses. So, if I got my null hypothesis and I've got my alternative hypothesis, okay, and like I said, I can rewrite this as subscript A if I wanted to. We're talking about the mean GPA. Okay, so what is the as I read this, what is the current accepted GPA of students in American colleges? 2.0. So I'll say this is 2.0. And now what do they ask to say? Is it different from 2.0? This would be not equal to 2.0. Say again? Oh, I'm sorry. Is that pretty easy to identify the hypotheses? Okay. We want to test whether the mean height of 8th graders is 66 inches. Okay. We want to test whether the mean height of 8th graders is 66 inches. Which hypothesis uses equality? The null hypothesis. Mu is 66 inches. Okay. So, if that's what we're trying to test, what would be the opposing view? Not 66. Just today, we're going to take baby steps. All right. So we want to test if college students take less than 5 years to graduate. Okay, we want to test whether they take 5 years or less to graduate. Okay, so 5 years or less. What would that look like? Less than or equal to 5. Notice that the null hypothesis contains equality, right? So the alternative hypothesis then would be greater than 5. Okay. Hold on. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So here's one where I think the way that it's worded, we can actually talk about which one's the claim and which one's not. These were just kind of getting us ready to use the words like is this establish the null hypothesis. So here it says now understand we're talking about a proportion now, so I'm not going to use the symbol mu, I'm going to use the symbol P. Okay, so my null hypothesis and my alternative hypothesis, okay, my null hypothesis proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, that is, and I'm going to write it as 0.61. That is because that is what the school is saying. We would argue that this is the claim. So we will either reject or not reject the claim here in this one. Does that make sense? Okay. What would this be? What would my null or my alternative hypothesis end up being? Not equal to 0.61. Okay. A consumer analysis reports that the mean life of a certain type of automobile battery is not 74 months. So here's the thing. H sub 0 and H sub A, okay, which one of those should deal with equality? The null. This phrasing is unequal, right? So right there, they're telling me the alternative hypothesis. Does that make sense? Okay. Is not 74 months, okay? This would actually be what we call the claim. That's what the report is saying, right? Okay? So then mu would be 74. Does that make sense to everybody? Okay. Yes. No. So what would happen here on this last one, as we do that testing, if I get data that rejects the null hypothesis, we say essentially that this is not true, then is that data that supports our claim? Yeah. Okay. If we say, nope, we have to accept this, then that would be data that refutes our claim. That says we were wrong. Okay. So that's just the introduction. Okay. Key thing here, we've got to know the vocabulary, got to know the notation. It can get a little fuzzy. It gets a little bit of, I don't know, people see subscripts and whatever, they start to freak out. So, or yeah, subscripts, and they start to look at the notation like that, and it worries them. Okay, if we understand what these mean, this should not be an entirely difficult process. Okay, the mathematics, I think, is difficult in hypothesis testing. The calculations, I think, are easy. Okay, I think you guys will kind of agree with that. Okay, but when I say the mathematics, that's the, what do I do when I reject a null hypothesis? What does that mean? What is the conclusion? How do I summarize that? I think that's mathematics. The way we interpret the data, okay, and interpret results, that can be confusing. So we'll take baby steps here initially. Okay. Like I said, no homework right now.